So, hello everybody, and welcome to my recording of my talk for Green IO. The talk I will be giving today for you who see this on streaming is practical approaches to measuring software sustainability via tooling and eco-labels. So you can see already it will be a lot about measuring, and it will also be about making this stuff visible. So I brought you two eco-labels, one more prominent and one bit smaller, which you probably know, like the SCI from the Green Software Foundation. And we'll compare a bit the advantages of these two approaches and how you can measure them with open source tooling. So since I said already the word measuring 3 times, which you guess now is the content of this talk very strongly, I want to take one brief slide by just talking about what can you measure in the first place, right? Because we work with very different clients in our company, and if you say measuring to one person, they have a very different understanding to what that means, being, let's say, for instance, like a product manager, to an engineer who might be working with CI/CD pipelines. So I just want to give an overview. What is there all that you can measure, and how we can maybe touch this also then later with different tools. So if you think of software, or say if you think of a physical product, it typically has something like a life cycle, right? It needs to be designed, it is used, it is recycled, or incinerated, so something like this. And software basically can be thought of in the same approach. So there's also something that is called a software life cycle. And for every of these phases, there are certain tools out there that can help you understanding what this particular phase has contributed to the energy consumption and the carbon emissions of your particular software products. What I brought you here in this slide is tools that we do at Green Coding Solutions, which are all open source and free to use. So you can also try them out if you get excited by the talk that I give here. And I just want to walk you through left to right. So when you start thinking about a software, there is obviously a development process involved. So you had the idea, you plan it a bit out, you're at your computer using maybe architecture tools to plan out the architecture of your software, you write down the requirements list, but you also fire up your editor, let's say, for instance, an example, VS Code, and you type in some code, right? So you get the application going. So this is all subsumized under the development phase of software. So everything that you need in order to sketch out the software and get the first lines of code in can be measured with a tool. For instance, we call it PowerHawk, but there are other tools out there, and they give you an idea. Okay, what has the development of this software cost? Like, what has it contributed? If you think about AI models, it can also be training of a model, right? So as long as it, for instance, happens on the development machines. But then after you have typically set up a first prototype, you typically move over to some more automated approaches and go for testing. Yeah, and you have then CI/CD pipelines that automate this for you. We have a tool, for instance, called EcoCI that plugs into GitHub and GitLab pipelines where you then can get emissions of your products. But this might be also phases if you think about AI models where training can happen, right? You have these pipelines, they run at certain intervals. We all know these cutoffs from ChatGPT, so they run at very fixed time intervals where they feed in new data. And this can be a very strong contributor to the carbon emissions of your software. So as here also separate phase, separate tools. If the tool then comes into something like the runtime, like where it's actually executed and the user interfaces with a finished product, this is what I want to talk about today mostly. So we do this with a tool that is called the Green Metrics tool, as I said, also an open source tool to try. And there you then can basically fix a number for the user has interacted with this software and solved this particular use case with it, and this has cost XXX gram of carbon or XXX kilowatt hours in particular. There's also some other tools which I don't want to go into details, some tools for monitoring and some tools when you want to report, right? Which is not technically a lifecycle phase of software, but definitely something that needs to happen if you want to be transparent about what your software is emitting. So this is all what you can measure about a software, and I want to focus about the runtime of the software product today in particular. And to give you an appetizer of what I will be talking about, I would like to sketch out why we believe, or why I believe, that measuring software is very beneficial if you are a climate-conscious company or a company that cares for the quality of their software product in particular. So as I guess most of the attendants of Green IO at least know, software and ICT is a very relevant carbon emitter in a modern digitalized companies. So if you go to the backup slides, but take my word here for now, what we've typically seen is that modern companies who use IT or run on IT exclusively have like 15 to 30% of their complete carbon emissions in the company is only from software and ICT. We have already solutions out there, as I said, like measuring has been in every domain so far. Before you optimize, you need to measure. We all know the statement. So measuring is the foundation of every optimization. Software is no exception here. But the interesting part, I guess, for the software and for the digital domain in particular, is that we already have digitalized these products. Like it's not that we need to measure very complex physical world processes where we need sensors, etc. Software runs already on devices where there's extreme amount of introspection possible, and there basically everything you can change, right? Like this is the name what software implies. Like you can tailor the infrastructure that you're running on, typically through software means also. So it is a very nice target to tackle if you want to optimize the emissions in your company, because it's such a big contributor, but also it's so easy to work with. There are already many good open source solutions out there, so there's no excuse of saying, oh, tools are too expensive or tools are not reachable. Like they're really off the shelf ready, right? There's also Scaphandra, which has been popular over the last years to be a very easy access tool. There are tools which are very cloud native, like Kepler, but also some tools from us that I will present to you today, which are very accessible. And maybe a small joke here as the last bullet point, the community, I believe, is already so mature that even if you have like no touch points so far with sustainable software, you can go into ChatGPT and just ask it for recommendations. It can recommend you tools, it can recommend you patterns. The data, it wasn't like this 3 years ago, but we're definitely there now. So tackling this is now is a very good goal for reducing your carbon emissions. The only thing that has been lacking so far was incentives. So obviously, some cost incentives come along when you do green software and your software gets more mature. But what you typically hear from very economic focused companies, at least, is like, where is the customer visibility and where is our competitive edge? Like, how can we show our sustainability efforts through, for instance, something like a label? And this is what I want to focus on today in this talk. So now I hope I have appetized you a little bit with what this talk will be about, but let me give you a couple of words of who I am as a person, so you know who is giving you this information. My name is Arne. I'm the CEO and founder of Green Coding Solutions. We are a company based in Berlin that specializes in software carbon reductions or carbon emission reductions. And we typically work a lot in research. So we do a lot of tools that we give out to the open source community. Sometimes they are originated from research projects that we have led. But we also do we are also an infrastructure provider who can help companies who want to measure their software, and we provide the infrastructure for that. And this then comes along with something like a consulting where we help companies making their software more sustainable. Like if you visit our webpage, I think this is the big claim at the beginning: we make software sustainable, so we help companies achieving these kind of goals. And in the bottom, you see a couple of companies that we've worked with, or some associations we are part of, like the Bundesverband of Green Software. But I will keep this brief for now. I hope you have an idea now who I am. So as I said, what I want to guide you through is why is measuring important and what can measuring of software sustainability give you. And I would like to tag along on an example where we did it with a client, Nextcloud. So I would like to tag along on a use case where we generated SCI values, and also we achieved the Blue Angel certification with them. So if you put on these goggles and look from the company perspective, the typical intro question, I guess, would be, why did Nextcloud want to get an eco label in the first place? So what are the reasons and the benefits for the company in getting this label in the first place? For those of you who do not know Nextcloud, so Nextcloud is an open source office management solution. So if you don't know what that is, it's something like Microsoft 365. So you have a word processor in there, you can do spreadsheets, you can do emails in there if you want to, you have a calendar in there, stuff like this. Yeah. However, the difference to something like Microsoft 365 is that user autonomy is a very high value in this software, and it's free to use, so open source. So the user basically is in control of its own data, and this is simply not something that you have so easily accessible in these bigger cloud products at the moment. On top of this benefit, which I guess is the USP of Nextcloud in the first place, but it's also an extremely modular and extensible software. Like, it has a marketplace with free extensions where you can bring any functionality in that you want. If you need a Kanban board also, you can just plug it in. And however, Nextcloud achieves its sustainability through a very performant core, because it's a 24/7 software. It has to be very performant because it's running all the time, right, on a machine. So it has to work with the resources that it has. And it is has a strong focus on also bigger multi-user deployments, where they put a strong focus on keeping this core at least performant. So the goals then for Nextcloud for going for this eco label are shifting the insight that they already had. I said before, it's already a performance software in its core, but they were looking at performance metrics so far, and now they also wanted to look at energy and carbon metrics of the software, additionally to what they already knew. So do they differ? Like, is energy maybe way different to, let's say, for instance, the CPU utilization, because there could be a lot of storage, right? And the question is why? Like, this is what they wanted to know. And then they wanted to steer a sustainable development of the software through something like an automated approach. This is something that we at Green Coding Solutions often call the green gate. So if you have already like a testing pipeline, and then you have these typical workflows, how software is developed, like let's say a feature is introduced through a pull request, you can also install something like a green gate that tells you, wow, has the energy consumption gone up with this feature, or has it maybe gone down by bringing in, I don't know, some optimizations, for instance. And they wanted to make the software more sustainable, but in a very focused way. So bringing in these green gates was also a goal of what we were going for, which then later on decided in the software that we used. And they also wanted to communicate their sustainability efforts, which then means, okay, they need something where potential partners and clients can see it. Like, they need a visible channel that has a high market penetration and can also give them a competitive edge. So this is why then in the end, for the Blue Angel for software, it was decided, because it can fulfill many of these boxes when it comes to communication channel visibility. So now I have said already I want to compare two approaches. I said I want to compare the SCI and I want to compare the Blue Angel for software. So let me put in a couple of words of what the SCI is. If you don't know it, the SCI is a standard or a formulation by the Green Software Foundation that basically says, if you have a software product, in order to tell how much carbon this software is consuming, you need to incorporate how much energy is it using, how is this energy generated from fossil fuels or from renewable energy, and how much embodied carbon does the hardware contain? Like, how much did you need to put in to produce it? And then this SCI, as it's called, the software carbon intensity, is always attached to a functional unit or to a use case. Like, what is it you're actually looking at? It could be a database query, but it could also be the operation of your whole software over 24 hours. So then I put in a how box where I kind of highlight a bit of the features or the interesting parts about it, and I will just go from top to bottom. So the SCI is quite nice because it is very free. Use cases are freely selectable, so it allows you to define system boundaries very flexible. You can say, hey, I just want to look at the database, or I just want to look at the end user accessing my website with a mobile phone, which is a strong advantage of the SCI, but it's also its biggest downside, because it makes whatever value comes out of it basically uncomparable to any other SCI, right? So another person can have said, oh yeah, I also want to measure how the user accessed this particular server, but for instance, I am not including the energy that comes from the network. I'm just including the energy that comes from using the device in particular. So this is a problem because in order to compare SCIs, you need to fix all the free variables that the SCI puts no strong visibility on. But it is very nice to iterate if you're iterating in your own company with a number. The measurement protocol is also not defined, so there's no guidance of saying, hey, you need to measure the energy every 1 second or something, or the energy for repeated runs has to be in a certain box. This is what the SCI does not define. The Blue Angel, in contrast, has strong requirements on what is it needed that is to capture. So for instance, the energy is needed to capture, and all the hardware components that you're looking at need to be very meticulously written down. And in addition, you capture also performance metrics. So not only energy and embodied carbon, like it was in the SCI before, you also capture CPU utilization, memory use, etc. Like disk use is also there included. However, it does not require to capture carbon. So it's a very energy-focused label in the first place. However, the Blue Angel allows to extra report it. So technically, you can report extra metrics in the Blue Angel. This is not forbidden, but it's not something that can be, for instance, looked at. If you take any Blue Angel reporting, there's no guarantee that the carbon value will be there. So it is an optional value, you could maybe call it. Additionally to these performance and energy metrics, the Blue Angel also captures the network traffic and the connections that are in there. So I think this is a very important metric because, as we know, network connections make up a lot of the infrastructure we need nowadays for communications. And it has also soft values like documentation must be provided, the API specification must be provided, and also uninstallability of the application must be given. So the Blue Angel is a label that also focuses strongly on user autonomy and long use of the software. This is also why export formats must be open, so that in case the software is not supported anymore at some point, the user can still continue using the software by exporting the data. So now again, on the how side, the question again, what is now the benefits, or what does the label make good and what does it make maybe not so good? So the use case must be a typical something that is very similar to the one from the GUI Software Foundation. The use case must be defined, but the use case here is targeted to what is the user actually doing later on with the application. So you need to create a use case for every possible functionality, or at least the top 80% of the functionality that the user can use the application for. So this guards you from excluding stuff that might be very key to the software and giving a more wholesome picture of the software that you're looking at. Also, the measurement protocol is very meticulous. You have to repeat the measurement 10 times. The measurement has to run at a certain time resolution. The measurement, at least the energy, cannot deviate more than 5% in between these runs. So you need to have very strong repetition possibilities. I think that's the word to use. And you need to also go through different phases, like the software is installed in the system. And then also you look at idle phases of the software, right? It's not like that you burst through a certain functionality, but you also look at how the software behaves when there's no user interaction at the moment with the software, which is for many softwares the case most of the time, surprisingly. And then in order to combat something like hardware obsolescence, the software must also run on a 5-year-old hardware. And it is finally verified by an auditor. So you can see already that the Blue Angel is a way more rigorous label in very many cases, but it, for instance, does not include carbon natively. This is a value you need to capture additionally if this is interesting for you as a company. So this is what I'm going to skip. It's just an overview of what the Blue Angel is, but you will hear talk about it later, or you can find it in the slides. It's just what you have to hand in just as an overview. And now I want to focus on what we have done, because we believe that both of these labels or standards are very, very beneficial for the green software community. So on the one hand, the Blauer Engel or Blue Angel for software is this very rigorous, very formalized label, but also the Green Software Foundation SCI, which is very flexible, but just needs to be a bit adapted or a bit guardrailed in order to make it comparable. And what we did is we integrated both of them natively in the Green Metrics tool as a measurement functionality. And then we went the extra step of certifying the Blue Angel, the Green Metrics tool itself with the Blue Angel, because otherwise you have this chicken and egg problem, of course, right? You want to measure new software products, but there is no measurement tool that is not also Blue Angel certified. So it would be nice if there is a sustainable measurement tool out there, and then you can measure. Then you can get the data from this particular tool. So just here is a small detour to get you an idea of what was the intentions for us of creating this Green Metrics tool in the first place. It is to have a measurement tool that can derive these two values. Here you get an idea of how a measurement then works. So again, we're looking at Nextcloud, at the use case. So because they wanted to have this native understanding of the application and how these energy metrics work, they also wanted to drill down then later into the components. So the Green Metrics tool goes the approach by saying we are going to modularize an application into the moving components. So for instance, a server is comprised out of very many Docker components. It can be a database, it can be the web server itself, it can also be the runtime, something like PHP, and you later have something like a client who accesses this software. So we put all of this in separate containers with the Green Metrics tool, and then later on can give metrics on all of these components separately, which gives a very strong insight into the understanding of the modularity and all the partial emissions of the software, so to say, of these moving parts. And if you are a company like Nextcloud or basically any bigger software company, you probably already have existing infrastructure that you want to reduce, right? So the measurement becomes more easily the more the tools can reuse what you already have. So an approach that we choose in the Green Metrics tool and is that if you have already architecture files, it can be Docker files, can be Docker Compose information, can also be a Kubernetes file or a Helm chart or whatever. The Green Metrics tool can understand that, and it can orchestrate the application from there. And then basically give you a head start of bringing this application onto a measurement benchmark to create these values very quickly. And then when you want to interact with the application, you can then also reuse stuff that you already have. It can be end-to-end scripts like Puppeteer or Selenium. It can be unit tests if they make sense, or benchmark or regression tests that you already have, session replays, etc., which makes it very easy to get the measurement going and then quickly derive a value like the SCI or derive a value like the Blue Angel for software, for instance, certification. The Green Metrics tool natively has the functionality to create these green gates, which was a requirement that Nextcloud have in order to go in. Here you see such an example. The software was measured. This is not from Nextcloud here, this is from a different software, but you can see that at some point in time, here on the left side, where these white lines start to begin, the software energy consumption, here particularly CPU energy consumption went up, and then you can drill down, oh, okay, at this point in time, something happened, and then you can click on it and get the information, okay, what was going on there. And then on top of that, you also get optimizations by saying, oh yeah, for instance, your container was booting way longer than usual. So there's apparently something going on, could be a race condition or something went slowly, or you had a network timeout or whatever. And this increased your energy budget, right? So they can really look into the application and see quickly, okay, what has led to the energy regression that we're seeing at the moment. And once you have measured all this, like you have basically set up the infrastructure, you have put your test cases in that you already had, let's say an end-to-end test, and then you did run this. I want to give you two examples left to right, how it looks like to creating an SCI value, let's say for Nextcloud. We look at the left side first. So here we have looked at Nextcloud and we have looked at the functionality in their application that is called Talk. So Talk is like an instant messaging tool inside of Nextcloud. So what we did there is we set up a usage scenario where two users communicate with each other and send messages back and forth. And then we derived the SCI value for it because the use case was sending these messages, and then we captured all the energy and the embodied carbon, etc., which the Green Metrics tool does natively. And then later you arrive at a value that you can communicate on GitHub or to clients, or you can use it in your marketing by saying, hey, sending a message with our application does cost 0.1 grams of carbon on this particular infrastructure, of course, for this particular machine. But this is a value we are optimizing against. Like we are maybe trying to get this lower, for instance, right? This is the communication you could do. Like this is a very flexible structure of the SCI, and you can get an internal KPI that you can use to make your software better, right? Which is very tied to a functionality. And on the right side for the Blue Angel for software, it is very similar. It's just differently displayed, so to say. And here we're looking at a different use case for the application. Here we did a calendar entry. So in Nextcloud, you have a calendar functionality. You can install a new calendar entry, and then it's available in Nextcloud. And you can see here that it has captured very many different values. It has captured how much was the processor use. Actually, they're talking here about not use, but they're multiplying it with the time, so it's percentage times time. How much was the memory use, how much was the disk use, etc. But then you also get an information in energy, like how much was the energy consumption for one user creating and deleting and changing a calendar entry. So how much does calendar management cost in Nextcloud? And you get an energy value attached to it. If you want to look at it in detail, I've also attached here the link in particular, but I think you get the idea. Again, similar use case is mentioned, but here the reproducibility is given by the standard. On the left side with the SCI, you have to bring the reproducibility in through something like a tool, like the Green Metrics tool, which creates these strong guidelines that a run basically is reproducible if you do it in, let's say, 2 or 3 weeks in time. Yeah, so now basically wrapping up, what were the insights? So now you have measured your software. So what were the insights for Nextcloud? So Nextcloud could, for instance, see after going through the Blue Angel certification that the browser that was accessing the application was 5 times more energy consuming than just the backend that was rendering out the application. And the cron jobs that were for maintenance of the database are an equally good optimization target as, let's say, for instance, the multi-user document editing. So the cron jobs took a relevant amount of energy, and depending on how many users you have, for instance, in document editing, it is as good as looking at the cron jobs at the document editing, which helps you steer sustainable software development of your software by finding high-value targets, with the energy values. Video calling was already very efficient and a quite low-value target compared to the other use cases we looked at, like, for instance, document editing and also like calendar management. And there was an energy regression in the front end. So I guess this is not something that is tied to energy testing in particular. Sorry, I guess this is not something that happens only with the Green Metrics tool. It happens basically if you look at your application at energy. There was no strong resource consumption, but still the browser was using a certain amount of energy because it was in a constant loop. That was, however, not really slowing down the machine in particular. And this would maybe not have been spotted in different tools, but only if you put energy as like a metric to the forefront. So the ideology of the application was already very good, which is quite good because Nextcloud is a 24-hour operation model. And as you can see here, takeaway from this slide, if you look in your application in detail and also use energy as an interest as your KPI, you surface sometimes different insights than it comes from pure performance testing, because especially idle times are very important, or especially times components that you might not include in a typical regression test, which is like an actual browser accessing your application. Typically use something like curl or like JMeter. They also can have energy bugs, which are very relevant for the user. So this is something interesting to look at. So what is the call to action? Now, after having seen here all these informations that I gave you about measurement, so measuring software application increases your own visibility of the software sustainability. And you can derive something like ecological KPIs by basically saying, yo, this is the energy consumption of my application or the carbon emission. But also it gives you more robustness for typical user interaction by finding, for instance, energy hotspots, by understanding the idle of your application, basically looking at all these different phases that a software can be into, which are different from just plain feature tests. And also the measurement output allows you to steer a sustainable software development through, for instance, something like a green gate, as I has shown as an example. The eco-labeling of the software increases the customer visibility and the market potential. We will hear about this also a bit more later from Philip, who also gives on the conference from Philip, who also gives a talk about that. But the Blue Angel is a label that has, at the moment in Germany, a 90% market penetration. So it's highly visible for customers. And customers are typically more likely to buy sustainability products. So once they understand that your software does something better than a competitor, by, for instance, using less resources or being able to run on an older hardware, this is a very strong incentive for customers to choose your application in particular. And the Blue Angel gives you the opportunity to make this visible. And still the community is growing for certified applications, so you still have the chance to be best in class. And as usual with everything that is new, interesting, and hot, the best time to act is now. And I hope I could appetize the topic of Blue Angel for software and measuring your application a bit for you. And would like to thank you very much for listening to this recording and this talk. If you want to see a bit about more what we are doing, here are a couple of links to our project and our research. You can find the Nextcloud case study under this link in detail. I only put a bit of stuff, obviously, today in the talk because of the short amount of time. And if you want to hit me up directly, there are my links here down at the slides. Arne, either on LinkedIn or email, probably the best. So yeah, happy to follow up on any questions that you have. So thank you very much.